All right, so tell me what you know about this.
It's going to be a V.
He says this is going to be a solid line. What'd you say, Arlie Beth?
It's going to be a V.
It's going to be a V graph. I agree with that. What else? I'm going to shade above. My Y is above the graph. Okay. What does that mean? What'd you say? The vertex is going to shift how many units down from the parent function, right? We got to keep referring back to that parent function. It's going to shift down, right? All right, so my parent function vertex starts at 0, 0. So this one's going to start at 0, -4. And if you recall, the parent function had a 1-to-1 slope on either side, right? So we can just plot those other points on a 1-to-1 slope. That's what the parent function had. We didn't change here in the front. We didn't have a dilation there, right? So if I didn't have a dilation, I didn't have a change in if it was facing up or down or reflection, then I just keep going like the parent function did. Yes? All right, so I'm going to put that on the graph. And I'm going to shade above. Interesting. Yeah, move your stuff. Where's it going towards? Is it? I see it. It's on the flag there.
It's like nasty water, too.
It's just dirty.
What'd you say?
I have water running down the wall. Thank you. Bye. Not sure what else I'm supposed to say there, but I have water running down the wall.
Is it going to be on YouTube? I heard it.
Oh, it is because we're still playing.
Cool.
All right, let's look at another while we wait on somebody to come check on the water running down the wall. The life of a real teacher, right? I made sure I said that really clear for my YouTube channel, my viewers. At least you know when you're absent, you still get all the humor of the day. You know what I'm saying?
Or you could hear somebody get in trouble.
Or you get to see her somebody get in trouble, yeah. All right, so let's look at another graph. It is absolute value. So what does that mean the graph's going to look like? A V. I guess I could have named that up here for our sake. This is absolute value inequalities. All right, so we've already said that this is a V shape. All right, what else do we know?
It's a dashed line.
Dashed line.
It's going to be above the line.
No, not above. It's less than, so it'll be below. Okay, what else? It's going to be a shift up. I agree. All right, what else? What does that 2 do? To do? No?
It dilates.
It dilates it. So is it making it wider or slimmer?
Slimmer. The bigger the number, the smaller it gets.
There you go. It stretches it. The bigger the number goes, it stretches it. All right. So from my vertex, I'm starting up 3 units, right? So let's think about this. If I put in 1 here, 1 times 2 is
2.
Plus 3 is? How much did that change from the point right here? Up 2 over 1? How much were we on the parent function? Up 1 over 1. So what did this number change? The slope of this side. So over here we would be able to do the same thing. And that is how that dilation works. On an absolute value. Now it works differently with the quadratic, but for the absolute value, this dilation just changes the slope. You with me? All right, dashed line. A little Morse code going on. And I'm shading where? Below. Some sunshine rays here.
Okay. It's too late.
All right? Questions?
I didn't. Okay. I'm just
I
gonna
didn't get the 2.
The 2 thing? So this number right here, it works like on the linears this as the slope. Right? These are straight lines, you agree? So it just changed the slope from 1. So up here it was 1, so we went up 1 over 1, right? On this one, it changed to 2. So now we're going up 2 over 1, up 2 over 1.
And that over 1, it can change?
No.
It's over
2 is, any whole number is over 1.
no, but like if that's a fraction over there, they would have.
That was a fraction. If it was like 1/4 or something, it would have pushed it down wider.
So like that can change. That's
Yeah.
okay.
So now you're starting to see how that works. Is everybody with me? Okay. All right, try this one then.
practice.
Oh, that was practice 2. Huh? I guess they didn't find it important that there's water running down the wall. That's probably what they said too. I would think it'd be kind of important. Everybody got it? Got a solution? Okay.
Yes.
No? Finishing up?
I have a question.
Okay.
When we do our, I'm just going to use the first problem
Okay, I'll go back.
as an example. When we shade over, do we shade like the entire top half of the graph or just everything?
No, everything
above?
in. So if this continued on, right?
Uh-huh.
And this continued on, it's just everything in here, right? It's just everything in here. So it wouldn't be this stuff out here. It would be
Gotcha.
just that in there.
Thank you.
Just kidding, video. You're going to have to wait.
Nice.
All right, here we go. So to answer Trinity's question, I said if this went out wider, we would still just shade inside the V, right? It's above the V. And then here, if it went out wider, we would still just be shading outside the V, right? Is everybody with me? Okay. So looking at this one, we had a shift of left shift, right, for 1 unit. We had a dilation that was going to make it do what? Slimmer again. Even slimmer. And then we said that the sign here was going to make it solid and above.
Why is it left if it's positive?
Remember, we talked about that H yesterday. Don't remember that? I want to look at that. We'll look at it in just a second again. But remember, it was because it said x minus -1.
Yes.
Remember that? Okay, so I'm going to shift my vertex of my parent function to the left one. I didn't have any up, so I just shifted the vertex to the left. And my new slope here is what? 3. Yep. Okay. So here's my new graph. You said solid line, yes? Ooh, that's a wobbly solid line. All right, and I'm shading where? Above, so everything in here. You with me? Everything inside it. Yes?
What's the shading thing?
That's telling you all those values in the shaded area. Okay, so this one says all the values in the shaded area and on the line will satisfy this equation. This one up here says everything below in the shaded area but not on the line will satisfy this equation.
Because it says below, right?
Well, because it's less than or
Greater.
this one was greater than or equal to. So this one included the line, this one didn't. Okay? All right, very good.